Hey folks, we're going to be talking about power today, electric power. We did mechanical power in the fall, but now we're going to talk about electrical power and how to estimate how much certain electrical appliances like computers and such cost to run. All right, so most appliances have a label on them. If you look on them somewhere, like here, this copy machine's got a in the back shows a rating of 120 volts, 60 hertz, 12 amps, and 1400 watts. And it's usually listed, the watts is right here, and that is what really tells us about how quickly and how much electricity it's going to use. Okay, if you remember from first semester, power is the rate at which energy flows or which energy is transferred. It's measured in watts. 1 watt is a joule per second. So if this copy machine is 1400 watts, so it's using 1400 joules of electricity every second. Right. So another example, 100-watt light bulb uses 100 joules of energy every second. Compact fluorescent only uses 16 joules. An LED uses less than that. That's one of the reasons why it's cheaper to use those other types of light bulbs. Okay, our equation for power, P equals I times V. P is power measured in watts, V is voltage, and I is the current. You can also write it, you can also use V equals I times R to get different values of V and I, and you can get different combinations of this. But if you stick with this equation, and if you're given a resistance and a voltage, then you can also find the current. Right, I'm not going to spend a lot of time doing practice problems on that because it is pretty straightforward. Right, so how do you get more power from it? And then looking at this, you can increase the voltage. Right, standard outlet's 120 volts. So you kind of, if you plug in something in, you're stuck with that. Right, you can increase the current. By increasing the current, you could reduce the resistance. Right, decrease the resistance to increase the current and have more power that way. Right, you can also to decrease the resistance, you can get a different gauge of wire. Right, notice the different numbers show the amount of different currents that will flow through it. The thicker the wire, the more current will be able to flow through it, as is kind of shown here. All right, so watts and kilowatts, we're going to have to be using kilowatts, just like in the last unit, when we were talking about current, we were having to use milliamps. Here, we're going to have to use kilowatts. Okay, so it's the same idea. It's still based on 1,000, but instead of moving the decimal to the left, we're going to move the decimal to the right. All right, so our base unit is the watt. So kilo means 1,000. Therefore, kilowatt is 1,000 watts. Right, so a 1,500 watt toaster oven is going to be the same thing as a 1.5 kilowatt toaster oven, right? Because we would do 1,500, and then we know a kilowatt is small. Kilowatt, you're going to move the decimals 1, 2, 3, and that'll get us to 1.5 kilowatts. Sorry about that. Not sure what happened there. 1.5 kilowatts. All right. Now, before we were converting milliamps to amps. Here now we're doing watts to kilowatts. So we actually end up moving the decimal place 3 to the left in this case too. All right. If we were converting kilowatts to watts, we would go the other way, 3 to the right. All right. So the reason we talk about kilowatts here is because one of the units of energy that we use, and we learned energy in the last unit as being joules, right? But the joule is a really, really, really small unit of energy. And the power companies have to charge us. When we use electricity, they charge us by how much energy we use and the rate at which it is used of the power. But a joule would be so small, they would have to charge like just like a millionth of a cent per joule. That doesn't make sense. So they use a bigger unit that's known as a kilowatt hour. Okay, so you buy electricity by the kilowatt hour, and the symbol for that is kWh. Right? That means you use 1 kilowatt of power for 1 hour, or 1,000 watts every hour. All right, so we're going to do an example here. Show you how to do this. 1,050 watts. Like for this particular case, we're talking about a coffee maker, and you see that the coffee maker's rating is 1,050 watts. Okay, and that's your notes written as 1,050. And it shows that the typical charge for electricity can be up as much as 14 cents per kilowatt hour, depending on the power company. It could be and what time of day you use it. It could be as low as 7 or 8 cents, and if you're using it at a really busy time, it can be as much as 14, 15, 16 cents a kilowatt hour. Right now, in your notes, the problem says the hair dryer is on or is used for 1 hour each day. I want you to change that to coffee maker because we're going to use this 1,050 here. Okay, so it's coffee maker is on for 1 hour each day. And how much will it cost to run each month? Okay, so basically we just have to figure out how many kilowatt hours are used and then multiply that by 14 cents. All right, so first thing we do is we convert the watts to kilowatts. So we move the decimal place for 1,050, 1, 2, 3. So it's 1.05 kilowatts. Do that every time, going watts to kilowatts. Unless you're given kilowatts and you just leave it the way it is. Right? Now we're going to multiply that by it being used for 1 hour per day. So now we're using 1,000. So we multiply 1.05 times 1. If it had been 2 hours each day, we multiply by 2, and so on. So 1.05 kilowatts times 2 times 1 hour. Right, if they tell you if it's used for 15 minutes, you need to convert the minutes to hours because we're going to be working with hours here. Right, so 1.05 kilowatts times 1 hour per day gives us 1.05 kilowatt hours per day. Right, now, we're using it for a month, and so we're going to say a typical month has 30 days in it. So 1.05 kilowatt hours per day times 30 days gives us, we use 31.5 kilowatt hours per month. To move sorry about that. I'm going to move my picture out of the way here. All right, and then move everything up. We see here that when we take the 31.5 and multiply by 14 cents, or $0.14, ends up being $4.41 a month to use. So not too expensive. All right, so let's do another example. All right, so here's a table with different power ratings for different devices and such. So if you leave your light on all day for a year, how much will it cost if the electricity costs 10 cents per kilowatt hour? Okay, so if we leave our light on, say the lights, we're going to look at the light, and we see the light's 100 watts, right? So we're going to say 100 watts equals, we move 1, 2, 3, 0.1 kilowatts. Okay, we leave it on all day, which is 24 hours, right? So we multiply 0.1 kilowatts times 24 hours, and that's going to be hours, 24 hours per day, right? So that's going to be 2.4 kilowatt hours per day. Right? And now, how long do we run it? For a year. Okay, how many days are in a year? 365 days. So it's going to be 2.4 kilowatt hours. Oops, sorry about that. Kilowatt hours per day times 365 days. And I can't do that one in my head. times 365. That's 876 kilowatt hours. And then we do 876 times 10 cents times 0.1. And that gives me $87.60 per year to run. Right? This is why sometimes our parents fuss at us about leaving our lights on. Because if you leave it on all the time, it ends up costing, and this is just one light bulb. If you leave on 10 light bulbs, that's over $800 a year. So you can see why it kind of makes sense to turn the lights off sometimes, or to get a more efficient light bulb would help too. Right? And then you see this very last little bit here is that if you add up all the appliances that you use, you can actually estimate what your electric bill would be. Okay. A little bit. There's a lot of things that are hidden in there that would be hard to calculate, but you could get kind of a feel for it. All right. So what I want you to do, finish this up. I just want you to practice the power equations. Real easy. P equals I times V. So do a couple of those and do a couple of the power cost practice. Both of those will be on Thursday's test. Right. Tomorrow we will do a lab where we're looking at the power cost. And then Wednesday we will review, and Thursday we will take our test. Right? I'll make sure that we get all log in together either Tuesday or Wednesday, so you can ask any individual questions. And at any time, of course, come in during Zoom, during class period via Zoom, and you can ask those questions as well. All right, y'all have a great day.